going to today, guys, we are going to do a little demonstration for you. It's called the Reactive Metals series. We are going to take some of the alkali metals and chuck them into water and see how they play. So we are trying to drive home the trend 4 in our notes from Monday, which is the reactivity series. Let's refresh that really quickly. So talking about on the right-hand side of the periodic table, Dr. Yates, can you talk to me about the last 2 groups and their reactivity?
Certainly. So we should remember that this last group here, group 8, we called these the noble gases. They're inert. They don't react at all. Period. Nada.
None.
We saw that last week with the helium.
Yes, that's why we did it with helium, right? So this, the next column in, here's our what we called our halogens, right? And our halogens, I probably shouldn't have started down there in our rare earths, but our halogens, their reactivity increases as you go up. Increases as you go up. Remember, our halogens are our most reactive nonmetals, and their reactivity increases as you go up. So fluorine, very, very reactive.
Wonderful. Yeah. And then today, though, we're going to be actually talking about the left-hand side, and we're going to be talking about the metals. So talk to me, Mr. Pilcher, about the reactivity of metals.
Well, your alkali metals with 1 valence electron, they love to throw that valence electron off into the wind so they can become that cation. So these folks right here are nice and reactive. Unlike nonmetals that get more reactive up the group, metals become more reactive as you go down the group. And so lithium is the least reactive metal, and then sodium is a little bit more juicy, potassium, rubidium. Francium is the big bad one here. That is crazy reactive. We're going to have some fun today playing with a little lithium, sodium, and potassium.
Awesome.
Yeah.
All right, if we wanted to start with the least reactive, that means we would start with lithium. Let's do it. All right, so we are going to start with the series at the top. So we are not going to use hydrogen. We've already done hydrogen, so we're starting here. And the least reactive is going to be lithium. I have a sample of lithium right here. It is in a bottle. It is in mineral oil because it is extremely reactive with air, oxygen, with water, with lots of different things. So what you're going to do is you always will see it in mineral oil. So I'm going to move it down here. One of the things about the metals that metals are shiny and these ones are particularly soft. So if you can see this metal here, it looks gray like you would expect a metal. It is a little shiny on one side. I can actually just cut this with a knife. This one isn't as soft as the other one. So, and then what you can see here is you can see it is extremely shiny, just like you would expect metal to be. On the outside here, it has oxidized it a little bit. It means it's react with the things around it. But as you see, the fresh cut shows you that shiny metal characteristic that you're looking at. So this one isn't particularly very fun and reactive. It just takes a long time to react. So I'm going to cut this down into a little bit of a smaller piece here. And we are then going to toss it into some water and see what happens. Beautiful. Let's take the excess away. I guess we could do smaller than that.
And yeah. I think that you should just go up and like point straight down at this one because we're going to do that with the other ones. You know what I mean? The part where you can see the difference between the oxidized color and the shiny metal is really good. Like
on that one.
Super nice.
Super good.
Yeah, you can really tell on the camera.
All right.
Zoom in on the base belly.
All right.
All right.
I can't, my lab coat didn't color anymore.
There we go.
All right. So now what we're going to do, just in case this decides to get a little bit of an attitude, we always want to turn that off. All right. So now what we're going to do, just in case this decides to get a little bit of an attitude, is we're going to put this over a little plate over here.
Just lost that. We didn't like. Oh, I had it.
Oh, there we go.
Right.
Nice.
Try it again. All right. Let's get it straight up, and then we won't move it because I don't want to lose it in the middle of the feed. All right. All right. So just in case this gets a little attitude, we have a little shield here. In here, all I have. Okay, hold on.
Oh man.
That would do nothing.
Yeah.
All right, just in case it gets a little attitude, I'm going to put this shield on here. We do have water, just tap water inside of the bowl here. And you would notice that when you usually have a piece of metal, it doesn't normally do anything when you put it in water. A penny will just sink. So anything that is a metal usually doesn't react. However, when I push this lithium into here, you can see it's starting to bubble. And it's kind of running around on top of that gas layer that it's forming. It's producing hydrogen gas. It's effervescing, if you will.
Just a cute little guy. He's just a little ducky swimming in the pond.
Swimming around. So again, it's obviously reacting with the water. So again, this is why we don't use a bigger piece of the lithium, because the lithium it reacts. It's a good little reacting guy, but it takes his good old time.
Like some
of
you nerds, get into class. Am I right? See that?
No, that was terrible.
That was a passive-aggressive remark that kids relate.
As you look down in your periodic table, after we have lithium, the next one down here is sodium. We're going to do sodium now. And we'll show you how we're going to take a little piece of this out, just like Mrs. Bay did.
Should be a little saucier this
A little
time.
saucier, yeah.
Getting lost in the
A few more electrons there to play with. So again, if you look at this is kind of a whitish metal this time. Now when we cut it, you're going to see it's going to have a bright silver on the inside like we're used to. Whoop.
Oh, yeah.
There we go. So now I want you to see where it was just cut. Much brighter, nice silver color on that on the fresh part where we cut it.
Nice and shiny.
Nice and shiny. So let's put the other first piece, what's left, back into our mineral oil. We don't want to have too much trouble with that.
Get rid of that, yep.
And let's take our piece of sodium in here. Again, we're going to use our little blast shield.
Let's go ahead and fry this turkey.
All right, if we're going to see sodium catch on fire, what color from our flame test earlier this year would you expect to see if sodium catches on fire?
I think yellow, right? Bright
Right,
yellow.
yellow color. Let's see.
All right, here we go.
Fingers crossed. It doesn't catch on fire. It's just going to be anticlimactic.
So it turned into a little ball, though, a little sphere.
Trying. Lots of gas again. It's fogging up in there.
Absolutely. You can see it's reacting more than the lithium is going much faster. The gases are gassing off a little bit more vigorously.
Oh, yeah, that's sizzling.
There you
Woo!
I probably should have done it that way.
See those fumes coming off there. Hydrogen gas. Hey, what would happen if you lit a match above that, Dr.
That's
Yates?
called a bad idea.
Oh, it's called the Hindenburg Part 2,
Hindenburg
baby.
Part 2.
We already did hydrogen last week.
He's
like
running away from you.
it.
That's like a duck on steroids. It's a lot
Yeah.
faster than the previous duck.
All right, so it increased its reactivity by a little bit. Let's see if we can't get it to increase again.
All right, kids. So we did lithium. It's like a little ducky calmly swimming on the pond. Sodium was a juiced up duck. Maybe it had some pixie sticks. I don't know. But now we're going for potassium. It's going to be a lot more sauce on this one. I unfortunately drew the short straw, so I have to do this. Makes me really nervous every time, and I don't like it. We're just going to get this over with. All right. Little bottle of potassium, again, mineral oil, so it doesn't get to play with any of the water vapor in the air. All right. Here we go. I'm going to grab a moderate-sized chunk out of here. Okay, there we go. Put the lid on. Get rid of this. Now, you'll notice that on one side of this, we got the oxidation layer. So it's pretty dark, if you want to zoom in on that. Pretty dark. But if I flip this over, woo, look how shiny that is. Nice. All right. So I'm going to go ahead and just kind of smush this one. The alkali metals actually get a lot softer as you move down to table 2. It's another trend. It's kind of interesting. All right, just going to kind of smush it. Smush, smush, smush. All right. I'm going to drop this in. I'm going to run away because I don't like this.
All right, ready? So here we go. Potassium in water, one of the most reactive metal we have. Let's go, Mr. Pilcher.
All right, here we go. Oh, it's stuck. I don't like that. Oh, it's stuck to it.
Just tap it on the...
Oh!
Jeez, man.
I like this. Okay. All right. Okay. All right. Here we go. And I'm running. Okay. I ran away. Oh! Oh my! That's why I don't like doing that. Oh my gosh! That was crazy. That was crazy. Oh my god! Look around the room. Look around the room. Oh my gosh!
Where's the flash shield, Mr. Pilcher?
It's in between me and oh my goodness!
Look at the
My heart rate's 123!
Oh, over the flash shield.
All right.
Look at the room! Oh, I gotta change my pants! Oh!
All right, guys. Well, thank you
Oh.
for coming. So that was a little more reactive, wouldn't you say, Mr. Pilcher?
Yeah, no, I would.
You like turned on my thing. All right, so here we go, Mr. Pilcher. If you thought potassium was a lot, we could get him some rubidium
Nope.
and some cesium,
Nope.
maybe some francium.
Yeah, if you want the feds to find you, here you go, Francium. Go get some of that. All right, now go take your quiz. It's Thursday. There's no school tomorrow. There goes the bell. Great timing. There's no school tomorrow, so there's no quiz on Friday. You gotta take it right now. I'm freaking out. All right. Okay.
Thank you, guys.
Oh! Oh, beautiful!
He's gonna spring back
I
up.
know my head.
No, go back up with it.
Think you might need some water
Yeah, right.
to
Okay,
wash
let's
that
try this
down.
again. All right, here we go.
All right. 12 times the charm.
I know, right? So again, this is why we don't use a bigger piece of the lithium, because the lithium does it reacts. It's a good little
takes
reacting
its
guy,
good
but
old
it
time.
takes as good.
Oh, I don't want to do this again. This is how much I did last time.
No, that's not. Are you
What?
crazy? Put that back in
You're
there.
the
Try
one that
again.
peer pressure me into doing that
Try
one
it
last
again.
time.
That is so big. That is
Smush it.
no, that's too big. Are you crazy?
That's how much
I'm
you
not
made me do
doing
last
this on
time.
my camera. That's not
Look at the
true.
flash shield.
Okay, so last time you weren't mom, and now all of a sudden mom
All right,
comes
put it back
shows
in
up.
there. Try it again.
Oh my gosh. Me.